Hello guys, welcome to my channel, and here I am in front of you with new video. And today we are going to fix it's Apollo treadmill, and it's a DC motor based treadmill. So here we have the card which drives the motor, and here we have the upper console, and these are the panel for start and stop. And first I'm going to plug it with the 220 volt. So here I have a 220 volt, and I always use series circuit to troubleshoot the electronics. So here we go with the play option, and when we plug it, after some time it shows error 2. So if we most of the time the error 2 is due to the motor. For example, if you have not connected your motor, your card will show you the error 2, but sometimes the problem is due to the motor, and sometimes the problem could be due to for the driver card. So first what you have to do, first you have to check your motor. So here we have the motor, and in DC motors we have two wires. So mostly people ask me that how to test a DC motor. So I have made another videos. I think I have uploaded 1 or 2 videos in which I have shown that how to check the DC motors. So anyhow, in this video, in short, I'm telling you that you can plug these two wires with the bridge rectifier, and you can check your DC motor. So in this case, I am pretty sure that my motor is okay, and what I am going to do, I am going to troubleshoot this card. So if I can zoom it, here you can see in this card, here we have the circuit, M positive and M negative for these two terminals for motor positive and motor negative, and here we have these two capacitors to drive obviously the capacitors are used to store voltages and for smooth operation. And here we have the MOSFET, and here we have the diode. So in whatever the type of card you have, whatever the brand you are going to troubleshoot, you will face or you will see the one MOSFET or two MOSFETs and one diode. So this diode is used to control the reverse voltages. So for example, since these are the DC motors treadmills, and these also can generate the voltages, so if you rotate these motors, you can get the voltage here. So sometimes it works as a dynamo. So if your motor is running and suddenly you plug it out and your motor is running, so in that case the voltages can flow in reverse direction. So that's why these cards are equipped with this diode for reverse voltages. Okay, so it must be okay, obviously. And now what I'm going to do, here I have the multimeter, and here I have the multimeter, and I have placed my multimeter on the continuity, and so here I have the MOSFET, and here I have the diode. So how we can say which one is diode and which one is the MOSFET? So there's one symbol, that D for diode, and Q1 for like your transistor. The Q1 codes are used to like represents the MOSFET or transistors. So what I'm going to do, I'm yes, this is drain, this is source, and drain and source are short. So these are short with each other, and here's the gate of this MOSFET, and this is also short. So this MOSFET is most probably, or in simple words, yes, it is 100% short. So but I will remove it, and then we will check it again. So here I have removed this IC and its MOSFET. Its number is IRF460. So, and now I'm going to check this. But the question is how we can check this. So place your multimeter on the continuity, and any two probes on two legs, because the first one is the gate. So it's source and drain. Yes, these two are short, and it okay. So this is short. So it's all three terminals like gate, drain, source, all are short. So this is faulty component. So here I have the right one, and I will replace this with this one. So but before that I have to check it that either it's good or not. So how I can do, in multimeter we have two probes, the the black one and the red one, so the anode and the cathode. So I will use, for in simple words, the black one on the middle leg and the red one the extreme left. So the reading should be around this, like it's diode. So it's mean that this is the forward bias from this direction to this direction, and if I revert the position of these two wires, and you will see the difference on the screen. So here we have no response, so it's mean there is unlimited resistance between these two points in this direction. And if we place, or if we measure the continuity between gate and drain, so here you can see there's unlimited resistance. So it's mean, and these are the condition that must be you can say justified by this component. So I'm going to plug it, and then we will check its behavior. Okay, now I have replaced the faulty component, and I'm going to check the work I did it. So first, yes, have you plug it? Start button. And now it's showing us error 3 because I have not connected the sensor over here. So now I am 100% sure that this will work, because the error 3 is due to the sensor, and I have not plug it with plug it here. So in the beginning of the video I told you that if we plug out these motors, the connections of motor, our card will show us the error 2 also. So since at that time my card was faulty, but right now you can see my card is okay, and if I plug it out, see the behavior, you can see the behavior. So what I'm going to do, again I plug it, plug in, powered up, no error. And if I just plug out my motor connections, and you will see the error 2 on the screen. So and the conclusion is the error 2 could be due to the motor, could be due to the faulty this component, and in short word, it's all about the drive of motor. So if error 2 is appearing, it's mean the problem is the problem could be with your motor, that could be with your drive systems or motor drive units. Thank you very much.